Hello and welcome to video 7, where we're going to discuss the parameters that were presented in video 6 and talk about how they're impacted by hydrology. So first we're going to briefly present the water cycle and then talk about each of the parameters. So hopefully you're fairly familiar with the water cycle. Water evaporates off the surface of water bodies such as oceans and streams and lakes. It enters the atmosphere and then it falls out of the atmosphere as precipitation. Precipitation can fall right back onto oceans and lakes and streams, at which point the water immediately enters the water body, or it can fall on land where it either infiltrates into the groundwater or it runs off into another water body across the top of the land. After water does infiltrate into groundwater, it can take a long time for it to eventually enter a stream or a lake. It can take months or decades, so that water can be very old, whereas runoff over the surface of the land can very quickly reach a stream. Here's another picture of that. Notice that there are variations in the soil. There's almost layers in the soil. So that clay, it's very difficult for water to pass through clay. It forms confined aquifers, almost underground lakes, that can be made of very old water that hasn't seen the surface of the land for millennia, which would be thousands of years. Once that water is trapped between those layers, it can travel laterally. So you can have some contaminants entering the groundwater at one point, and then if it's kept up due to a layer of clay, it may travel sideways rather than straight down. And here's another example of some contamination traveling sideways. And notice that it could travel out in a circle as well, away from a specific source of contamination before it hits a lake or a stream. And again, it may take a long time for contamination from a spot to reach out to that stream, or it may be very quick, depending on the characteristics of the ground. So our first parameter was temperature. Now the surface water is generally tied very closely to the temperature of the air in general. Groundwater, however, may be a very consistent temperature, again, depending on the characteristics of the soil. So in this case, it shows that groundwater on average is about 42 degrees Fahrenheit in New Hampshire. And that corresponds very well to the average nighttime temperatures. But notice that means that it's not changing temperature very quickly in the summer. It's not heating up and then cooling down in the winter because it might be so disconnected from the air. The second parameter was stage, and recall that this was the depth of water in a water body. So stage can be very connected to groundwater. There's maybe 3 different kinds of streams that we could think about. So for instance, a gaining stream is water in which the groundwater might be slightly higher than the stream, and so water is flowing into the stream. A losing stream would be groundwater is slightly lower than the stream, so water might be flowing out. And then a disconnected or a perched stream might be even separated from that groundwater. But notice that if the stream is disconnected, then it better be getting a lot of water sourced from another location. For instance, maybe a melting glacier, or lots of other streams that are connected from to the water table. So trying to think about where the water is coming from kind of helps you understand stage. Stage is a very common parameter to collect because it's fairly easy. Just stick a ruler in it. And then watching how that stage changes over time can help us find out some things about the stream. Another thing that we can find out about the stream based on the change in stage over time is how urbanized, or else how paved, the watershed is. So this graph shows 3 different reactions to a rainfall event. The tallest one there is after urbanization. So the stream's watershed has been very built up, very paved, As rainfall falls on that watershed, it runs immediately off. You can picture water falling on a parking lot. It's going to run right off. It's not going to take any time at all. The one before urbanization would be, so before that parking lot was built, maybe it was a forest or a garden there. And so rainfall falling on a forest or a garden is going to be held up some by the soils and the plants. It's not going to be so quick to run off. And then stormwater management techniques might be to build gardens at the downstream end of the parking lot. So maybe we can help retain some of that water so that it doesn't run off so quickly. Now, you may have noticed that this graph is labeled discharge and not stage. So it's showing the flow in the stream, and that's cubic feet per second. So how much volume of water is moving per second. And there are ways to calculate that flow from stage, but we won't be talking about that in this unit. It's a little bit more advanced than we're going to do. If you're interested in it, however, you certainly can look it up on your own. The third parameter that was discussed in video 6 was electrical conductivity. And I first wanted to separate out hydraulic conductivity from electrical conductivity, just so you don't get confused if you decide to do some more research on conductivity. Hydraulic conductivity is how quickly water moves through the soil. So water is going to move much more quickly through gravel than it would through sand. Electrical conductivity is how well electric current moves through a material. So in this case, we're looking at water. How well does water carry electrical conductivity? And that varies depending on what type of water it is. Here is a picture of the electrical conductivity at a site in New Hampshire. And here's 1 year from January 12th to January 13th. And notice the shape of the curve. So if you know that rainwater is essentially distilled water, think about it, it evaporates off the surface of water bodies. It's not going to bring any salts or any minerals with it. So it's going to have very close to zero electrical conductivity. It's unable, water itself, just a pure H2O, has a very difficult time carrying any electric current unless it has some salts in it. Salt water carries electrical current quite well. So rain events are going to drop the conductivity. So notice this large event here in the middle around the 29th and the 30th of October. That was Hurricane Sandy. So a large amount of rain fell in the watershed at that time and really dropped the conductivity of that water body way, way down. So that's one of the things you can tell from electrical conductivity. You can compare it to parameters such as precipitation and perhaps try to figure out how much of the water came from precipitation versus how much of it comes from groundwater. Dissolved oxygen is the fourth parameter, and in video 6 I feel like we already talked a lot about the factors that impact the amount of dissolved oxygen present. So the temperature of the water, the plants that are available, the moving water, if it's entraining oxygen or not. So I won't talk too much more about dissolved oxygen. pH. Now, water in the Northeast up here in New Hampshire tends to have a pretty low pH. You might have heard of acid rain. We have a lot more acid rain in this part of the country than we do in other parts of the country. So why is that? Well, the main reason is that there's factories in the Midwest, and those factories produce smogs and so forth, and the general wind direction is this way across the continent. And it pushes that pollution over, and if it rains when that pollution is above us, the water falling out of those clouds, out of that pollution, has a low pH. It's acidic based on the chemistry of the smogs involved. So we tend to have low pH in this area. Now, why doesn't that happen for the Midwest or for California? Certainly there are factories elsewhere. And one of the reasons is that the Rockies kind of protect the Midwest from the same situation. The Rockies kind of block that smog from coming across. And California is protected by the ocean. The smog isn't able to make it over the whole way. So you may see pH in this area changing based on rain events or as different compared to rainfall that is in other parts of the country. So I just liked this graphic of some of the impacts that you might see in surface and groundwater. If you're interested, you can pause the video and take a closer look. And that is video 7. So please go to this link and complete the content quiz. Thanks for watching.